Hello, welcome to episode 158 in this series where I am programming an NES game live on Twitch from scratch. Let's get into the code refactoring again. So, last episode we did a ton of code refactoring, and I thought that went quite well. And so I figured we'll do that again today because, well, we got to finish what we started. Shout out to Felipe for pointing out that I was missing this RTS in the comments on the recording, so, or in chat somewhere. But regardless, yes, thank you. You were 100% correct that was missing. But we are not in a position where we are actually building again, so let's get this fixed and then we'll worry about that here. Entity logic tables. So process a little bit is not there, really? Is it a case thing? Process little, yeah, it is. So, oh, you know what though? I do want that to be uppercase because that then is consistent with, I believe, the entity name itself in the project. Oh, no, it's not. Okay, well, I want to try and be consistent here. So let's do that. Like I said in a previous stream, this stuff will hopefully all get to be auto-generated moving forward. But for now, we're just kind of like proving out that this actually works. So we're doing by hand, which is fine. Process bullet. Process game. Okay, so now these are... So this is the old loop where we were looping through and we were loading the entity type and we were saying, hey, what is this thing? Is it a spawn point? Is it an explode? Is it a player? Is it a cloud? But the answer is, or the problem is that we've changed all that to work like our game state processing. So all of this code is effectively not needed anymore. So we can... Does that work? It does. Oh, it knew how to do that. Cool. I don't know if I ever tried that before. Let's control forward slash. It actually understood how to comment out the assembly properly. So that was nice. Okay, so we do want to do this. We do want to load the type because that is still relevant. But actually we don't want to do it here. What we want to do is we want to go to, we want to say JSR. How did I do this with, what did I call it in the game state? We had process game state. Okay. So we'll just call this process object. Right, that's a pretty straightforward name for it. Process object. And proc segment code 0. Very good. And then this code is essentially going to be very similar to process game state. So I'm just going to kind of, well, let's code it up just so like we actually pay attention to what's going on. So right now, we're going to call that within this object loop call. And X is going to contain the index of the object that we're currently processing. So we're going to load A with our objects plus and the type X. So, you know, get the actual object we're processing, and then we want to shift left to multiply by 2 because the addresses are 2 bytes in size. And then we have our table of entities, which are somewhere over here. Entity logic tables. So what we're going to do is we're going to load a with entity logic. Oh no, we want to, okay, so problem with this is we're using X to look up the type, and then we need to use X to do the processing here. So what we probably want to do is we need a either we need a variable, or we have to establish some sort of pattern or process for how this is going to work. So I think what I'm going to do what we're going to do is we're going to do an unnecessary push here, only because we're going to expect that the index we're using is on the stack when we come back. That might be a dangerous assumption. I'm trying to think if there's a better way to do it. I mean, the logical way to do it is we would just have a variable that we would use for this, and only this, so we don't have to worry about it being modified. Maybe that's what we'll do, because pushing and pulling stuff off the stack for this kind of seems wasteful. We can use this variable to keep track of where we were, and we don't have to worry about X getting clobbered by anything. So we'll just call this like EP index, entity projectile or OP index. How about that? OP index, because it's the object and projectile index. And so we'll put that into the 0 page. Reserve a byte for it. And then where's process game? There it is. So we're gonna store it before we actually do the loop. We're gonna initialize that index, and then what we'll do is we will just load X with OP index, right? And then we'll call process object so that X has the appropriate index in it already. We don't have to worry about, let's do this though, increment OP index. Okay. And then maybe one other thing we want to do, we can do that here. Because if the entity type is 0, there is no entity. So let's just say branch if equal to skip entity, right? And skip entity is just going to use RTS. We're going to return because there's nothing to process here. Otherwise, we will shift it for our lookup into the table. And so we'll load A with, what did I call it? Entity logic tables. Is that the actual name of the table? It's entity RTS table. I didn't think that was right. Entity RTS table X, and then push that, and then +1 X, and then push that. Yeah, I thought I can never remember which byte comes in which order. Obviously it does matter. All right, so push that on, do that, and then we're going to call RTS to go back to, or not to go back to, but to go to the actual subroutine to process the object. And so that'll mean that when we come back to here, we'll have processed the object. All of this stuff is now no longer necessary, which is nice. So let's see. One of the things I was thinking about is, do we need to process the entity type outside of the subroutine and say, like, okay, if it's 0, then just go to entity object complete. But yes, that might technically be faster, but at the same time, let's not worry about that right now. Let's just get this working. It's faster because we're not doing the subroutine jump, which has to push the 2 bytes onto the stack only to then have to return from the subroutine by popping or pulling the 2 bytes back off and jumping right back. But again, it's not really that big a deal. So now that we have that, we've incremented the OP index. We can then load A with OP index so that we can do the comparison. We're going to, right, let's see. So yeah, so we're gonna clear carry, add carry the size of entity, and then transfer A to X. Oh, because it's got a error. So actually, sorry, so this increment is actually not correct. Because it's not a 1 byte array of entities. So, right, so let's do this here. Load A, clear carry, add carry, size of entity, and then store a OP index. I forgot. We'll do that here before we call. So get rid of that. But this is good. We'll just load it, check it against our upper bound, and if it's equal, we're done. Otherwise, jump. Someone's coming down the stairs. Am I in trouble? What did I forget to do? Am I making too much noise? I don't think so. Okay. You never know. All right, so yeah, so let's put a comment here. Let's just say increment OP index with the size of the entity, so it's ready for the next entity on the return. Process the object. Right? Simple. So we check here, and then if we are equal, we are done. You can even just do this because I don't think we need this to be a special label anymore. Otherwise, we want to loop back to process object loop. And then here we're now into the projectiles. So let's worry about that in a second. See how this assembles, if there's anything Process object undefined. Oh yeah. Gotta include that or it's not gonna know about it. Yeah, cool. Okay, so that's good. That is what we wanted there. We'll see if that actually works the way we want it to. And then, so now we need to create one called process entity. Sorry, projectile. And this is going to work basically the same way as process object. The only difference is that it's going to use the projectile table instead of the object table. So we could even, let's go back to this before we get any further. Transfer x to a and then store a into op index because we're done with that. Okay, and then we're going to move. You can see we've got similar logic here for the projectile where we're incrementing the index. All right, so load a projectiles plus projectile type x. Yeah, maybe. I think that's the right syntax there for that type, that struct. All right, so then we've got that, and then we're going to shift it left to do the same multiply by 2, and then we're going to assume that that is consistent here, but we'll find out in a second if I name that incorrectly or differently. And then we RTS. We want to just branch of equal to skip processing projectile. And what did I do here? I have 2 RTSs. See, I could have just easily just left it like that. All right, so is that what I named the table? Is the big question. Projectile RTS table. It is, okay. And I have the +1 first, like we need it to be. So, all right, process game, we can get rid of this and instead just call process projectile and get rid of all of this logic. And then before we do anything else, we need to load X with the op index and then load A with the op. Oh, actually transfer A to X, sorry, X to A, and then clear carry. Right, we add the projectile size and store that in the op index. Are we double loading it here? We are. That's silly. Transfer X to A. We've already got it loaded. No reason not to do a register to register. TXA, clear carry, add carry, store, call the subroutine. We don't need to do either of those. Compare. We need to do this. Load A with op index and compare it to U-bound projectiles. And then if we're done, we have that. Otherwise, go back to the loop. And then we are doing draw sprites here. So that's that. That actually did a decent job of kind of cutting down some of the code related to the object logic there. So let's see if this builds. Process projectile, right. So we got a same problem as before. Should really be plural, I think. All right. No. I go back on what I was saying. Singular is fine. Okay, so we have that now. Okay, now the question is... load X, transfer X, blah, 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 blah. What we'll do is we'll just kind of step through this and make sure that this all looks correct and see if there are any issues with it. You know, the funny thing is I could see us even further condensing this down into 2 subroutines, because you could set it up where, into 1 subroutine instead of having these 2 separate loops, where you call it twice, just setting up the different values. So like you could pass it the address here and then the offset of the type potentially, and then the address of this table. But I feel like that's a lot of messing around for not a lot of gain. Like, it's not such a big deal that we have these 2 loops here. We've already done a good job of separating it out. And then the nice thing is you can see clearly what it's processing. And if you want to turn off the projectiles for some reason, you can. Where's my NES controller? And let's see if this is broken or working. It is broken. Okay, but that's fine. Kind of expected that. Let's go to our code and process game. Let's see, where's process game? Process game is here. Let's see what's actually happening. Once we actually go to process it, the objects. Probably some silly mistakes, but that's fine. So I'm actually not concerned too much about this. JSR process object. More concerned about this because this is the really new stuff that we did. Okay, so OP index is 0, but we're going to store 0 into it anyway. So at the beginning of the loop, we load the value, we transfer it into A, we clear carry, add the size of entity. Oh, why? What? Yep. So first mistake, got to use the pound. Without the pound is not a numeric value. It is trying to load. I don't know what it was even trying to load there. All right, let's try again. Okay. Load X, store it, load it, transfer, clear, add. All right, cool. So we have a value of B now instead of 0. We're going to store that, so that now has the value of B. We're going to process the object, so we're going to step into that. We're going to get the type, and the type is 3. So it is not 0, which means we don't skip the entity. So now we shift it, we can get 6. We're going to load the first part of the address, which is 94, and push it. And then we're going to load the second part of the address, which is EF, and push that. So let's go. That's 94EF, which should be process player. Right, process player. One, two, three. Oh, it's the cloud. Okay, that's fine. I was incorrect in what I thought it was, but that is okay. Process. Where is cloud? Okay. So that's where we should be, which is going to, which is 948B, but it's going to 94EF. Where is the current instruction? Oh wait, we're in process object. So just to confirm, this was, X was 0, so value we got was 6. 3. 0, 1, 2, 3. So it's a little bit, but that's that's not right, because 0, we got to make room for 0, even though 0 is not a valid entity. It does need something in the table or it won't work. So what this is going to is process a little bit, which is in little bit, or should be. What is it going to? Well, let's find out. Let's step. Process explode. Okay. Well, but it is just going to loop it through again and add 4. Huh. Wait, so okay, 4 is the type, right? So 8, 0, 1, 2, 3, 4, 5, 6. What is entity type 8? All right, let's stop for a second, because this is should I? Let's do this. Let's create something called process problem, that if somehow it calls this, it's gonna cause the game to stop. Just gonna have a break instruction. And then we got to add it to shooter.asm. This can kind of be a catch-all for any sort of issue there, but we needed to put that in because we don't want to use entity 0. That means there's no entity, so let's just fix that and then go back through the code here. We don't need this breakpoint right now. Okay, so we've got that index. index is 0 in X. We've updated OP index, and then we step into there. We grab our type, which is 3, and we load the address 98EA, which is what? So you can't really go to it. Oh, wait a minute. No, stop. 98EA. Skip processing projectile. It's not EA98, right? Nope. All right. What do I do here? 98EA. Process projectile, but why? Go back to this for a second. Processing. I don't care. So I'm just looking at the raw assembly right now without the source because I just want to see something about what is this doing. So it loaded 3. I thought 3 was the player entity type. It is. So did I just have do I have a mismatch in my table? 0, 1, 2, 3. Yeah, I do. Okay. So how did that happen? Explode. Oh, because 2 is a bullet, which is a projectile and not the player. I think I talked about this last time. So we gotta skip. Let's do this. No entity projectile. Oops, projectile. So cloud, and then again we have process problem. That's one enemy projectile. Then a little bit spawn point, palette swap, camera. Okay. Now the flip side is that we've got to have all these placeholders for. Maybe this is not the right way to do it. Maybe we just have one table. If we have one table, then we only really need the one function. We don't need both. I guess that's probably better anyway. Even though I've logically split them up into different parts of memory. Oh no, if I've split them up into different parts of memory, we do need 2 different functions, but the table can be the same. Okay. That's fine. I'm okay with this because it will simplify this process. It'll be easier to generate too. Okay. So where is process projectile? There's only one table now, which is still just entity, entity RTS. We'll probably rename that here just to reduce confusion. All right, let's reload the ROM. Process entities. Code process game. So it is 98EA, which should be the player. 98EA. Where's that code? Player. Why is that still wrong? 0, 1, 2, 3. Player. Nine eight E8. 98 E8. 98E8 is this RTS. Why is that the address that it's loading? Unless it's E898. Nope. So, I mean, this is going to be... Yeah, that's wrong. So, what did I mess up here? Process problem is 0. Process explode, process bullet, process player, process cloud, and these are all -1. Process problem. Player. Player is 3. That's that. So what? All right, let's take a look at the table itself and see what's going on. The table is... and the RTS table, which is at 98B7. We can just go to memory, actually. 98B7. So player 0, so 0, 1, 2, 3, right? So 98B0. Or sorry, 98B7 is that. So 0, 1, 2, 3. 95BE. Which, if we go this way, 95BE, 95BE, 95BE. Hello? That's not valid address. 948A, 9448A, 8A. Oh, wait a minute. Sorry, I didn't have the... I had the code view still on. 95BE, 95BE. Oh yeah, process player. So that's the RTS. Oh, that's why. Okay. That makes a little more sense. Because it's doing address -1. So it should just be going into here. Right? Like if I go back to this view. I go back to process object. Process game. Where is the instruction? Oh, we restarted the game. Okay. Process object. 98E8. But where, why, who? Because X is wrong. Oh yeah, X was totally wrong. Oh, dummy. Okay. That was stupid. That is just down to definitely just being tired. So yeah, after we multiply it, we have to transfer it to x. Otherwise, it does nothing. Process projectile. I really need to go to sleep earlier. I've been staying up working on things, and as you can see from the last few streams, that has really affected my ability to focus and get stuff done correctly the first time. The problem is sometimes, you know, you're like, I want to work on something, and the only time you get to do that is, you know, starting at 10 o'clock at night. And that is not helpful when you're trying to get some sleep. So 9.5BE. 9.5BE. Yeah, that's process player. Great. So now we do RTS, and hey, we're in process player. So now we're just gonna do checks to make sure that we aren't at the end of the list. So now we go to the next object, and we're gonna load the type, and it is 4, which I believe is a cloud. And there it is. Okay. Let me see something. That's if we want to clear the object. Okay. There is this return that can happen there. That's if we're done with the object. Okay. I think good to just kind of let the game run. Okay, so cloud is there. Chip is sort of there. Some stuff is wrong, but better than before. The game is not totally crashing. So let's take a look at what that looked like when we started, because I didn't really see it. Okay, so a bunch of stuff kind of flickered into that sprite. Load a projectile type X branch of equal. Shift left, transfer A to X. Skip there. Otherwise, we return. That is entity RTS table still, so that's fine. Process game. Process object, and then when we're done, we check to see if we're done with the objects. And if we are, we skip over this loop. Let's see. Open the debugger and just make sure we're not unnecessarily. Oh, you know what? I think I know what the problem is. The problem is that I believe all of these routines expect X to have. They do. So they all expect X to have the value of the offset for the entity being processed, but there's no guarantee that that's going to be the case because we're doing these lookups here. So what we can do, thankfully, is load OP index into X before we do the RTS, and that should solve the problem for that. We don't need to do it if we jumped to skip process projectile. But we do if we actually tried to process an object by loading up the stack with the addresses. So, yeah. Oh, stop hitting breakpoints, please. So many breakpoints. Okay. What's going on with this? Unofficial opcode. All right, so something happened here in process game that it did not like, but that's okay. Let's figure out what's going on with the player controls, because I am not able to move the ship right now, even though some of the stuff is working. Ship is not moving. Okay. So process player input. Is that being called anywhere? Process game. It calls it there after the sprite stuff is done. Is that actually being called? Seems like it is, because the game behaved slightly differently when I tried to shoot. Process player input is being called. Okay. So it's processing the player input, and when it processes the player input, what does it do? It is just looking at the object's entity and doing some stuff. So X. Here X. Okay, so it's going to loop through the projectiles to see if it can add the projectile, add bullet. And then it calls RTS when it does finish controls. Is there any other jump that's going to jump out of this? That would be a problem. Finish controls. Jump check up. It's weird that it's breaking player movement, since that's hard-coded to entity 0. Player.is. So this is actually using X to determine, so that's fine. Checks if it's alive. If it's not, it does a return. Let's see if it's even processing the player beyond calling this, because I know I saw that it looked like it wasn't at some point, but that also was while we still had the bugs that we were fixing with the table jump. So, right, the debugger is running. Went here. Right, so the player is alive. So it's loading neutral. It's getting the timer, comparing it against the camera counter speed. Load A0. Resetting the timer. Getting the position. Doing a subtract. Figuring out where the player is on the screen based on its world position. Doing some convoluted checking. And that's it. That was really it. So there's nothing... That's weird. There's nothing super complex about the way that that works. Wait, where was it calling process player input? I saw the subroutine was called, but looking at the code now, I actually don't see where that happens. Oh, it's right before. So that's okay. I did check to see, and it is calling that. So why is that not affecting? Where does it check the controller? Process game state. Okay, so it does update controller and then process game state. And so in update controller, it resets and then it stores off that info. So I don't know why is it not letting the ship move? That's bizarre. Controller is definitely hooked up. Okay, adding projectiles definitely breaks things. So let's see. Let's see what's going on here. Let's take a look at the projectile code. Reload the ROM. Okay, I don't care about that right now. Let's see when we actually... Right now we don't have anything. Then that is 4. If we look at this, 0, 1, 2, 3, 4. Why? Bullet should be 2. Is 2. Oh, it's 4 because, okay, it did the multiply. Okay, that's fine. So load X, the op index, and then process bullet. Okay. Check bullet collision. Or if a Y position X4. That seems wrong because the projectiles I thought were bigger than that. Oh no, they are just 4 bytes. Okay. For some reason I thought they were bigger than that. Size of entity and size of projectile. Transfer X to A, clear carry, add size of projectile, store it into op index, and then we just check here. So that's all correct. That's really bizarre. I don't know why things are getting stuck like that. I mean, this is good because it's showing that we have some sort of entangled code here that I was not fully aware of. So we just got to figure out what's going on. Not exactly the most fun thing to be dealing with, but we'll figure that out here in a second. So that's the bullet type, and then it just processes the bullet and compares it, and then it goes back, and then it looks at the next one, which is nothing. And then it's going to just keep looping through, basically, which all the rest are nothing. So what I don't understand is why that is not actually processing the projectile properly. See, does that script still work? I had that script that would draw the entity table and the projectile table onto the screen. I don't remember if this still works or not. I think the sizes might be wrong. It has the entities still. Oh, it does look like it's trying to do it for the projectiles too. Oh, it's turned off. Oh, -1s. That's never a good sign. But you know what? That's also probably because the size is wrong. Yeah, projectiles, address. So, yeah. It is 012 is the type. So let's go back to this. Okay. Why are you still getting the wrong type? Projectiles address +2. Oh, entity sizes. It should be projectile size is 4. This is all sorts of not correct. Projectiles address. You know what? That's probably not correct either. No, you're not going to help me with that one. Okay, process projectile. Let's see if it'll give me the address here when I mouse over. No. If I look at the code a different way. 98DE, 98DE. There. The address is 5E9. That's wrong also. All sorts of things are screwy with this script. Oh, it's now saying -1 for all the projectiles. 0, 1, 2. So it should just be 0 for the projectiles. Have the address listed in here. It says the symbol, the scope, a bunch of other stuff that I'm not sure what that is. I don't understand why. Give me a hard time. Projectile. 5E9 is projectiles +2. So 5E7. Script. Ah. Okay, let's see what's going on here. Yeah, so it is. Did add a, well, that should be 4, not a 2. Process game. So player, add bullet. Oh, it's process player input. Add bullet. Compare X to U-bound entities, finish controls. Projectiles, projectile type X. If it's no entity, then branch if equal to add bullet entity. Get the player position and offset the bullet. Look at the X position, X position, and clears and adds 4 to that, and then stores that in that X position. Projectiles Y, bullet type, or oh wait, it is 2. I keep confusing because it becomes 4 when we do the table lookup. Okay. Sorry. So that is correct. So why does it lock up when we add a second bullet? Because we get this. How does it get this instruction like this? What is this even? What's the matter with this? Thing invalid. That it's an invalid instruction, but that's a little weird. Unofficial opcode. Because it jumped to... Yeah, so it jumped to 8D13, which is this, not this. So how did that happen? How did that happen? Because we processed an additional projectile. Load entity, Y positions, set the carry and subtract 2, check the bullet collision, then store a, you know, this could potentially be part of it. Store a, check, store it and check if we carried, store it and check if we carried on subtraction. That's potentially going to be a problem when we call subroutine for... But why wasn't that a problem before? Let's do this. Let's take a look. Well, I guess it was calling that already. Store it and check if we carried on subtract. Basically, because if we carried... If the carry is clear, then we need to remove the projectile because it went past the bottom of the screen. otherwise, we're good to continue. I guess what we want to really do is do this. I'm going to subtract, check if it's off the bottom of the screen, and then do this. Check the bullet collision and then clear. Oh no, wait, sorry. If we didn't hit the bottom of the screen, then check if we collided and return. Look back at the old code and see how that worked, if this doesn't change anything, because I don't remember exactly. We're getting the unofficial opcode. Something else is going on here. Check bullet collision. There's something broken in this too. Push, transfer, push, push. Oh, we're pushing the processor flag. Okay, okay, that makes sense. So, Right, so actually this is okay the way it was. And it's okay because the processor flag is pushed and then we pop it off. We must be doing something wrong in there. We're pushing A, transferring X to A, then pushing A again so that we've stored A and then X and then the processor flags. Maybe what happened was we're doing an RTS too soon. And I don't see one. Thought maybe we were RTSing out of here before we should have, but it doesn't look like it. And that would have meant we would have had something on the stack that would have caused us to have a problem when coming back from these calls. So, process player, what is it called? Player bullet. What's going on with this? That it's causing this weird behavior. So X is 4 coming in. But if X is 4, that seems wrong. Because process projectile. Oh, it is wrong. It is wrong. It is wrong. And okay. So in my attempt to do the math early, I messed up the code I wrote later because I forgot that we're doing this before. So actually checking the next entity instead of the one that we're currently processing. So what we got to do is the following. We want to load A with op index, and then we'll store it after we're done, but we'll do the compare. So I think that'll fix the problem, because we're doing it too early, and then I mean, it's correct in the sense of what I was trying to do made sense, which was we can pull op index for our value of what X is, to be able to retrieve it again, rather than pushing and pulling off the stack. But if we're going to increment it before we call process projectile or process object, then that's not going to work because we're going to be one object or projectile too far in the array. So load op index. We don't need to do that. We just do clear and add, and then store, and then compare, and we are good there. So let's rebuild. Let's see. That would make a difference because we're looking at stuff that's one too far in the array of objects and projectiles. So that could potentially be causing this kind of a problem. Aha! So the ship works now. Oh, we're still getting unofficial opcode for the projectiles. Why? Weird that the ship worked okay. Load-x op and why are we loading this in A? We don't need to do that now. We can just store X. X load X. Make sure. Let me just make sure the entities work fine. I won't do any weapons fire here. I just want to make sure that nothing freezes up or breaks as we add the enemies on screen. All looks good. That explosion worked. Try and avoid it this time. Yeah, that's all looking like it's supposed to. Player ship is maneuvering correctly. Can fire one shot at a time. But if I do a second one, it's causing a problem. Okay. So let's see. Load X, store X, load X, op index, jump subroutine, process projectile. Check the type, skip processing, ASL transfer X, load, push, load X back in with whatever op index was. Call it, come out of here, we load A with op index, clear carry, add carry, size of projectile, store it back into op index, compare it to U-bound particle, projectiles. Then if we're done, we do that. So, I mean, the only thing it really could be is the code in here, which is pretty simple, but it gets the, I mean, it's working fine with just one. That's pretty strange in and of itself. Oops. No GeForce experience, thank you. It's funny that that sprite doesn't, the hardware sprite doesn't get cleared out. Weird. Very weird. What does the memory look like? 5E7. 5E7. There's the first 4 bytes, and then this is our second projectile, and it is no good. Okay, so is add object the problem? Player input. This is the problem when it adds the bullet. For a second bullet, it's no good. So load X with 0. Compare X to the U-bound of entities. Oh. No, that's not good. U-bound projectiles. How did that... Whoa, all of this is kind of screwed up. How did that not cause problems? Wow, wait a minute. That's crazy. How was this not a problem Oh, actually, this is okay. Yeah, this is okay because we need the player one, but like the rest of this stuff, that was definitely wrong. Because this is looping through the projectiles, and then we're getting the X and Y position of the player. My position. Okay, yeah, that's fine. Weird, weird. I can't believe that that's got to have been wrong for a long time. Where's my script? Let's take a look at that now. Yeah, keep going. Stop it. Okay, that's fine. Nothing's broken yet, so let's... Whoa, whoa. Okay. Nice. That's working now. Quite spectacularly. So there is that bug, though, that when the bullet hits the enemy, it seems to get frozen in place. But if you look at the entity data within the script here, you can see that it's no longer a valid entity. So this is probably a case of where when it collides, not clearing out the sprite, just clearing out the entity type. Load A. Yeah, so load A, then store A projectiles plus projectile sprite Y. Clear the sprite, the bullet sprite. Because if you remember, we changed to separate the type from the sprite, so it sees a sprite and it's like, hey, let's draw this, even though the entity is not tied to it anymore. So that's probably what that was, but we'll find out in a second. Yep. Come on. Yep, it's gone as soon as it collides. Cool. And then once we get to the edge of the map, we'll have the right palettes and stuff. I'm glad I kept this around because this actually ended up being pretty helpful. But what's cool is that all of this stuff is now broken out into subroutines, and the loop that checks it is pretty self-contained, very simple. And you can then look and see the different calls that are being made all throughout. Well, that's interesting. So 3 and a 1 and a 1. What are the ones? Explodes. There are some explodes that got left over. That's interesting. I have to see why that is. But we can see now, if we sort for average cycles, we can see what our most expensive subroutines are. And also like how often we call them. So we can see like check bullet collision is up there, but it's, you know, it's like 1.5% of our total code. If we look at like what's taking the most time, NMI is taking the most time. Besides reset. Reset is the actual function that's, you know, not even really a function. It's like if you're programming in, you know, C or Java and you have your main, right? So like, of course, that's where most of the time is, because that's where That's your actual main function call that the application is running under. And then NMI is the same thing. It's being called 60 times per second. Check bullet collision, process projectile, process bullet. Process projectile is being called a lot. Why is that being called so much? Oh, right. That's being called, yeah. So for every projectile we have, yeah, that makes sense. Every projectile, I was thinking projectile like an actual object, but so for every projectile we have in the list here, potentially, we are calling that. That gets back to that optimization I was talking about earlier, where we can do, we'll make this change and then I think I'll wrap. I know this was well, actually it was an hour and 20 minutes. Okay. I was going to say, I think this was a shorter stream, but it's not. It was a pretty decent chunk of time. So yeah, so what we can do here is we can do a little shortcut where we say objects plus entity type X and then branch if equal to this and just skip. Right? So basically we're just saying don't even bother processing the object if we see that it is a non-type, if it's no entity. And then we can do the same thing with projectiles. Projectile plus, no, type X, branch if equal to there. So that's a handy little thing because this way we're not calling the subroutine if there's no point in doing it. Just saves us a little bit of time and some clock cycles, because you can see we're sorting by percentage, and it is taking up a pretty decent amount of time calling this with almost nothing in process projectile being actually done, because there are no projectiles currently being dealt with. So let's see now. We take a look at our profiler. We should see that if I fire, process projectile will maybe pop up, but it should only be there. Yeah, so it got called 60 times because the bullet was on screen for a second, and now it's bumped up a little bit because I fired a few projectiles, but it's not being called anymore because there is no projectile to process. If I press it again, it will pop up a few more, and now you can see percentage wise it's a far smaller percent of the overall time than what we had before, because we're not needlessly calling it and having it just pop right out again. As I exercise that function to process all these bullets I'm firing, it will kind of come up again, but as time goes on, that percentage should drop, because more and more code will execute and more cycles will pass. Process object, there's not much we can do because we've got the player object on screen, so unless the player dies and then there's no sprites on screen, it's always going to need to be called anyway. But we should be calling it far fewer times now because we're not processing non-entities with the subroutine. So I think that's good for today. Obviously, we still have this problem with the way that this is working, and we also have the problem of, oh, it's not even a problem, it's just we've got a lot of code in here dealing with scrolling, but I feel like we've actually done a really good job of kind of paring all of this down. This is only about 600 lines now. All the different pieces are kind of their own things. Like we've got stuff really kind of split up. This bullet collision, that's about 120 lines. You know, there's nothing that I'm seeing that's like really massive anymore. Which is what I was going for. You know, there's stuff that we could still probably do, but I feel like I'm ready to go back to working on getting level 1 working some more. And as we see things here where we think that we can be a little bit where we think we can maybe be a little bit better at organizing our code, we can come back and fix those things. Some of these things are one-offs. Like I mentioned this another time, we've got like this one-off where it's getting stuff ready to load into the character RAM. Eventually that will become a little bit more versatile and handle the multiple levels, because part of the reason we're using character RAM is so that we can be a little bit better about how we load our tiles in. And then we're setting up our, so we're just clearing out our memory for sprites here. And then we're in the main game loop, which updates the controller, processes the game state, and waits for NMI to finish before we do it all again. That's pretty straightforward. So, all right. So thanks. As always, thank you for watching. If you want to reach me, I'm on Twitter at Clairvis. I am on Video Game Sage as Zelius. But you can also find me on Discord as Clairvis. If you want to email me, it's zelius@gmail.com. I do have a Patreon. I have all sorts of stuff that I try to post there, but obviously not required. If you pre-order the game, you get access to the source code. I've got to do a major update for these refactorings we did. Thanks for stopping by, Mira Lupa. And what else? Yeah, and feel free to ask questions in the description. Sorry, below the description in the recording if you want to do that. And have a good night, and I will see you on Thursday. See you later, Drozrix. Thanks for stopping by, and see you Thursday. All right, bye.